Welcome to Automated Visual Software Analytics. This part is about software analytics in practice. We will give a motivation and a problem statement related to an example scenario. We will show how to create software maps and how to explore and analyze this example system. Let's start with the motivation. The example scenario is related to a shipwrecked system, a shipwrecked software system called XY. The XY system has been developed over the last 10 years. The software system provides an industry solution for object inquiry, presentation, modification, distribution, and storage. So it's a very broad topic underlying this example system. The functionality includes a complex functionality, especially based on computational geometry, 3D computer graphics, data management algorithms, so it's a non-trivial system, including different user interfaces, different applications, and different application programming interfaces. So it's a complex system in every respect. The implementation. What about the implementation? The major parts of the system have been implemented in C++, and the source codes have been managed with a standard version control system. Yes, this system can be called a legacy system from the company's perspective because it's a key asset of the company and its services and products. So what happened to this system? The project was somehow shipwrecked and stopped recently. Why? There are several reasons for this event, including new features appeared in one release but disappeared in the next release. Features remained or became unstable. Most required key features could not be implemented in a reasonable, given or defined time frame. And even minor changes resulted in major new developments, including the development of whole new subsystems. In summary, in the last years, the team hardly achieved their goals, in particular in the last 2 years, with respect to time and with respect to the given budget. So at this point, the investors realized that further investments require fundamental changes in the software and with respect to the team. Exactly at this point, software analytics comes in because it helps to solve this kind of situation. The investors required what we could call a software due diligence. So a new management wants and needs to explore and analyze the as-is situation and to understand the system's structure, its quality, the software quality, its development history and evolution, and of course this team has to identify principal weaknesses. To decide whether to invest new money, for example, the investors and the management decided for a data-driven approach based on software analytics after receiving many subjectively shaped stories from all team members and explanations from different team members, including the CIO, different consultants, and the former CIO. All these stories did not converge, however. So at this point, it was unclear what is the as-is situation because due to what people told, it was not clear. Furthermore, all people did not provide an overview of the entire system in terms of software quality and software quality measures in particular, nor about the evolution of the system. What happened in the last year? Why did the development change in such a negative way? The investors in the new management ask for decision support, for example, regarding a better team setting, reusing options for existing system components and maintenance strategies, and estimations of costs by applying methods and techniques of software analytics. Now, we are going to analyze this example system. By the way, it was a real system that recently came to us and is to be investigated. So we take this system as a good example because it shows many facets of real-world projects. Yeah, how to create software maps. As software analytics tool in this example, we will apply the effectiveness platform that analyzes and evaluates software systems and their development processes based on predictive and prescriptive software analytics. It's a state-of-the-art tool, so we want to show you this platform because it includes most of up-to-date techniques and technology. The effectiveness platform can be used to automatically integrate all relevant software engineering data of a software project, and it helps you to translate the results into different types of so-called actionable insights. The effectiveness platform supports software metrics for a large number of programming languages. Most common programming languages are covered. For common revision control systems, even for systems for issue and bug tracking and other collaborative software development services. So it has a strong integrative characteristics. Yeah, this effectiveness platform and how to use it will be explained right now in form of a short tutorial by Felix. Felix works for Software Diagnostics and is an expert in the effectiveness platform and in software analytics.
I'm Felix Salfner, and I'm going to demonstrate how to do the analysis of an actual software system using the effectiveness platform. The effectiveness platform consists of two parts. One part is an analyzer that you download and run on your machine in your environment that actually analyzes the source code, the version control system, etc., creates the analytics database, and this database is then uploaded to a web platform where you can access the actual software maps on your browser. In order to start the analysis, you have to create an account on our website, and so I'm going to create a demo account, OpenHPI demo user. I provide an email address, openhpi@softwarediagnostics.com, and a password. I have to agree to the conditions of use and I sign up. You will receive an email to verify your account. In order to download the local analyzer and to start the analysis, you have to log in to the platform. And you have to create an application. In order to do that, you need to provide the company who owns the software and the name of the application. In this case, it's XY System. Click Next. And this is the download page for the software that you execute on your local machine. In this case, I run this on Windows. I've downloaded the tool, and this is a command line tool, so I cannot double click. I need to copy this to the directory where the source code is located. So I move it from here to the source code location. Open up a command line and start to initialize and to execute the analysis. The steps that you actually need to take are listed on the web page. So if I click Next here, I see all the commands that I need to execute in order to start the analysis on your machine. Okay, now I execute this command on the Windows command prompt. So I paste it here and start the initialization. In order to verify that I'm actually allowed to upload something to the platform, I need to provide my credentials again. So open HPI at softwarediagnostics.com and the password. And now the next step is to configure the analysis. Configuration. In the configuration, I provide the details where the source code is located, etc. So I go through the options. In this case, it's a Git repository, and I need to provide the location of Git. You can also access it directly from GitHub if you have your source code on GitHub. In this case, it's on my local file system. And I don't need a username and password here. And I finish the configuration, and the next step is optional, so I can check whether everything is correctly configured. And yes, it is. Okay, and now I can start the analysis. So basically, the local analyzer now checks out the source code and runs all the analysis here in the background. And the analysis is performed and prepared on your local machine. A couple of minutes later, the analysis is finished and we can upload the data to the platform. The data is uploaded, and now we can switch back to the effectiveness platform. You see the screen has changed and it's waiting, it's preparing the actual software maps. In the meanwhile, I can add some additional information about myself, about my role in the company, before I can explore the results. After the results have been prepared by the effectiveness platform, I click on Explore Results in order to see the software map that we're talking about. There's a little tour explaining what you actually can do with the map, but I close the tour here.
Felix, you have shown us how to set up this software analytics tool for a specific project. I would like to ask you some questions. What about interactivity? For example, if I look at this map, I see this red tower. How can I find out more about this specific one?
So in fact, this map is interactive, so I can move the map with my mouse and zoom in to find out what exactly I'm interested in. And looking at this building, I see that this is a very large software artifact that contains a lot of complex nested coding.
Ah, okay, I see. Let me ask another question. What about a typical project size? When can customers start to use this effectiveness platform?
So this platform scales from small applications to huge applications that we have analyzed from big customers. So actually, the approach scales across all software sizes.
A last question. What can we expect in the future from this platform? What are you going to integrate next?
So we learn a lot from our customers in order to provide the software map themes that really target the questions that our users have. And so we will fine-tune those map themes, and additionally, we will add prediction and prescriptive analytics so that we can analyze all the data that we have. We can provide benchmarking so that all our users can make the right decisions supported by our platform at the right time.
Yeah. Felix, thank you very much for introducing us to this software analytics tool.
You're very welcome.
Coming back to our example scenario, the XY system. What happened to this system and its development? This software map here shows one aspect of its history. The software map shows the knowledge distribution. It's defined by the ground size taken from the lines of code measures. The height of each cuboid represents the McCabe complexity, and the color encodes the number of developers that have touched the modules in the last year or during the last year. So what we easily can identify is that large part of the system, counting the red and yellow blocks, that large part of the system is known to only 1 or 2 developers, and this is generally considered to be a big risk because only few people know and operate on large part of a system's implementation. So this might be one aspect of a possible explanation to what happened to the XY system. So the key insight here is most code is owned and known by only a few developers. This is achieved by applying software analytics, using software maps, and by analyzing the underlying source code and implementation and repository information. Let's have a look at further functionality provided by software analytics tools. For example, they help to make the management of software development more effectively. They help to monitor especially key performance indicators such as software metric values over a long period of time. They can also be used to define so-called objectives, project objectives, specific to modules or subroutines or subsystems or any component of your implementation. An objective represents a specific goal specified by target values that you would like to reach. Target values with respect to software quality metrics, for example. Reducing the McCabe complexity would be one such goal. And they are specified by a time frame in which you would like to achieve this goal. In general, software analytics tools help you to get informed about trends in advance. So they act as a kind of early warning system. This way, they establish a proactive risk and problem management in your software development processes. Let's summarize the findings of this part. Software analytics tools such as the effectiveness platform we have seen today provide instruments to put software analytics in practice. Most processes that are required by such tools, by software analytics, can be fully automated to provide an up-to-date information basis and decision support platform at any time. Software analytics tools can be applied to projects of any size, ranging from small first-time projects to the management of large legacy systems. So they are not limited to a specific project size. And there's another aspect that is very important for the long-term development and progress in software analytics. Software analytics is also key to enable a cross-project benchmarking that will help project teams to take advantage of predictive and prescriptive software analytics findings distilled from a large collection of projects can serve as the information basis for a software analytics early warning systems. So individual projects can take advantage of, can learn from the whole collection of projects that is monitored and watched and observed by a software analytics platform. Yes, this concludes our part about software analytics in practice.